Good morning, class. And these are the numericals which I had asked to you on the basis of our lecture calculation of EMF of the cell. And now in this video we will discuss these numericals. Okay, so let's start with the first. This cell reaction which given to you shows that uh, Zn is converting into Zn plus 2. That means the oxidation of Zn and reduction of silver is takes place. Okay, so the cell will represent like this. At left hand oxidation occurs, so Z and Zn plus 2. Then the salt bridge, and at the right hand the reduction takes place, so Ag plus and Ag. As we know that the EMF of the cell, that means the E naught cell, as these values are standard conditions, so I'm writing the E naught cell. So E naught cell equals to that the right hand side EMF and the electrode potential, sorry, standard reduction potential at right hand side and standard reduction potential at left hand side and right hand side reduction potential. Okay, now let's the values which you have given a values of oxidation potential here. Okay, that means the value of zinc to Zn plus is 0.76 and this is minus, and we need the reduction potential value. So at this point you need to understand that a standard oxidation potential, okay, standard oxidation potential of zinc electrode zinc electrode and silver electrode, this you have given, are given. Standard oxidation potential of zinc electrode and silver electrode is given to you. Okay, now what is the standard reduction potential? Because this is the standard reduction potential, so the standard reduction potential, this is the oxidation potential. So as I told you that this is a vice versa process, so this is minus 0.76 volt in case of this, and in case of this reduction potential will be plus 0.80. This you need to understand. Okay, so now we will write the right hand, that means this one, so this is given to you 0.80, and then minus left hand, this is given to you is minus 0.76, so the value will be 1.56 volt. So this is your answer. Point to be noted, the value given is your oxidation potential Zn to Zn plus 2 and Ag to Ag plus. Okay, and you have to convert this value into reduction potential, so this you need to keep in mind. The value is positive, that means the cell reaction is favorable, that means the cell reaction is correct. Okay, the next which you have given the second question, and that is a logical question. This question, one of the question which I had also already to you in my video. So this is a logical question. The question is that can a solution of 1 m copper sulfate be stored in a vessel made of nickel metal? Given E naught, that means the standard value of nickel to nickel plus 2 is plus 2.5, and copper to copper plus 2 is minus 0.34. Okay, question is what? Can a solution of 1 m copper sulfate be stored in a vessel made of nickel? So what this actually this question says that we want to see whether the following reaction will take place or not. Reaction is what? Nickel with copper sulfate. So this will give nickel sulfate and copper. If you write in the form of oxidation, so nickel copper plus 2, this will give Ni plus 2 and copper. So this actually we want to know whether this reaction will proceed or not. This is what the meaning. Can this copper sulfate can be stored in the vessel, a nickel metal vessel? So let's represent the cell first. So the cell representation will be like this: nickel 2, nickel plus 2, and then copper plus 2 to copper. This is the cell representation. Okay, now you have given values of oxidation potential. This is the oxidation potential value, and this is also the oxidation potential value. So let's write the EMF of the cell. So the EMF of the cell is nothing but E naught cell, that is equals to E naught right minus E naught left. This is the right hand side, this is the left hand side. Okay, so now I'm directly going to calculate, because see, we have given values of oxidation potential and here we need to write the reduction potential. So the value you have given is oxidation potential. Oxidation potential of E naught copper plus 2 is minus 0.734, so 0.34, and nickel to nickel plus 2 is plus 25 volt and volt. This is the value you have given. So what is the values of reduction potential here? So reduction potential, we can write the reduction potential. So reduction potential will be E naught uh, copper plus 2 to copper. This will be plus 0.34 volt. Okay, and E naught nickel plus 2 to nickel, this is minus 0.25 volt. This is what the difference. Given values are oxidation potential, you have to convert these values into reduction potential, so the sign will be changed. So right hand side then is the copper, so value will be 0.34, and in the left hand side the value is of nickel, so nickel value is minus 0.25. So when you combine this you will get 0.59 volt. 0.59 volt, what does it means? The value is positive. This shows that if the value is positive, what it shows? It shows that copper sulfate react with nickel. This can be react, that means the reaction can be proceed. So copper sulfate can react with nickel, and if copper sulfate react with nickel, you cannot store copper sulfate in nickel vessel. Hence, copper sulfate cannot stored in nickel vessel. So this is how we can find out the answer of this logical question, that whether the copper sulfate solution can be stored in nickel made vessels. So this is not possible, because nickel can easily react with copper sulfate, and if it is easily react with copper sulfate, you cannot store that. So these two questions which I asked to you, uh, these questions was based on the EMF calculation. I hope most of you are able to answer in the similar way, and if it's still not, then you can click this video and watch the solution. So thank you so much. We will meet with some other questions. Thank you so much. Now the third questions: can chlorine gas be stored in a copper vessel? So this is the question, same as previous which we have done, like in case of nickel and copper sulfate. So here also we need to identify whether the reaction is process or not. copper chlorine reaction. Okay, so let's talk about the reaction. And before that, you have given value is copper uh, E naught, copper plus 2 copper. This is given to you is 0.34 volt, and E naught Cl2 Cl negative. This you have given 1.36 volts. So again you should note that the values which you have given to you is the values of reduction potential value, point to be noted, because here it is from plus 2 to 0, and here 0 to minus 1. It is 0 to minus 1, so 0 to minus 1 is the reduction, and plus 2 to 0 is also reduction. So these two values are of reduction potential value. So let's solve the problem. Copper plus Cl2, this will give Cu Cl2. Okay, so we have to find out whether this reaction is possible or not. So let's draw a cell. The higher value which you have given is the value of Cl2 to Cl negative. So higher value is always a value of reduction potential. So here the oxidation occur of copper. So let's try and let's write the cell copper to copper plus 2, and sorry, Cl2 Cl minus. So this is the reduction, this is the oxidation. And then E naught cell of E right and E left. Right hand side is this value. This you have given 1.36, Cl2 to Cl negative 1.36, and copper to copper plus value is 0.36. Okay, we need to write the reduction potential value. This is the reduction potential value, 3436. So this is plus 1.02 volt. Plus 1.20 volt means, that means this reaction will proceed, and if this reaction will proceed, we cannot store chlorine into copper vessel. We cannot store chlorine into copper vessel because reaction will takes place. Okay, so this was your third question. Thank you so much.